Let's get into it. This is take the path of least resistance for your test data. All right. So who am I? I started out as a lead QA engineer. That was 8 years ago. Now I'm the lead test engineer at ReviewTrackers. I've worked at a couple different companies. I run the Chicago Selenium meetup group. Attas.me is my website if you want to learn more about me. So some caveats for the talk. I am not a RabbitMQ expert. I've only done the RabbitMQ tutorial and I've only programmed one consumer. I don't know why they invited me to this talk, but hopefully they invite me back and they like it. So we'll find out at the end of the talk how I did. And some other caveats is like, this is from the point of view of the tester, me, and in a system that uses RabbitMQ, how to take advantage of it with the knowledge that I have from my point of view. All right, so quick outline of what I'm going to talk about. First, I'm going to give you an overview of the company where I work, ReviewTrackers. That's important for future examples. I'll go over how tests work at ReviewTrackers, how data moves around in production using asynchronous programming and message bus such as RabbitMQ. We'll talk about how to utilize the way that data moves around to do that for tests. And then I'll talk about some other great uses of RabbitMQ for end-to-end tests. And then if we have extra time, there's some extra credit where I'll make some jokes. What RabbitMQ, a piece of software, has in common with software testers, which are humans. Hopefully we'll be able to do that. If not, I'll just leave those slides up in the background during Q&A. So some goals that I want you all to have for attending this talk. I want you to be able to write end-to-end tests so that when they fail clearly. They tell you what went wrong and you know where to look. Other goals are, we want you to be able to migrate data around in a natural way for tests. We don't want you to do things unnaturally. I want to talk about the advantages and disadvantages of doing things this way. And you'll also be informed testers when you know more about RabbitMQ and the RabbitMQ internals. So first things first, overview at ReviewTrackers. ReviewTrackers is a review aggregation platform. Basically, let's say you're Pizza Hut. You create a ReviewTrackers account. We go out on your behalf and collect your Facebook pages, your Google pages for every location that belongs to Pizza Hut. And then we'll get all the reviews on behalf of you for those locations and those URLs. And we'll put them in one place so that you don't have to manage hundreds of URLs. And then we'll perform NLP, natural language processing, on those reviews so that you can identify trends in the reviews left by your brand or for your brand, and you can respond to reviews in the platform. It's just for aiding marketing managers whose job it is to manage online presence of their companies, and they can use our platform and get access to all those reviews in a convenient and easy place. Okay, so a little bit about the tech stack. We use a microservice architecture. We use React, API, and Golang. Databases are Postgres, and then we have a large main application, kind of asynchronous programming microservice that we call MQ, because that does a lot of RabbitMQ stuff. And then we have a ton of other microservices that do one specific thing really well. We've got the Elasticsearch microservice that handles search within the app. Amplify is another microservice we have, and that's kind of a microservice for if you're Pizza Hut and you want to have a widget on your website that shows your hottest reviews, you can, the Amplify microservice takes care of that. It selects, the ideal reviews and then live loads them on your site. Insights is the one that does that natural language processing to get those trends out of your reviews. Falcon is the one that's responsible for getting the reviews and maintaining data about the locations and the URLs associated with those locations. So that's a little bit about the stack. So how do tests work at ReviewTrackers? So really, people use the term end-to-end tests, but I call these tests that I preside over database to DOM tests. That's a term from Titus Fortner, who's a Selenium contributor. So what do I mean by database to DOM tests? I mean, they're very white box. They know what the shape of data is in the back end. They know about APIs. They will use that information to get data in place to do a front end end-to-end test. So I always preferred the term database to DOM test because these are smarter tests. They're white box. They know about the internals. We run them heavily in parallel using a Selenium grid infrastructure. They run in CI/CD. They take around 10 minutes for the whole suite. With our team of developers, they run it, about 100 times a day. And then right before deploy, the tests run, and we do a lot of deploys. So these tests get a lot of use. Within our infrastructure, we also have microservices declaring queues, and we have consumers in various microservices listening to routing keys sent by other microservices. So there's a lot of cross chatter between the microservices. There's a small difference between our CI/CD environments that is kind of interesting. So for the CI suite of tests, those run in an ephemeral Kubernetes stack, and those the stack gets booted up, we run the test, then they get booted down. It's an isolated environment behind a VPN, and those use a Kubernetes RabbitMQ Helm chart to boot up their Rabbit instance. But in our staging environment where we run the CD tests, there we use a Heroku stack, and that uses Cloud AMQP in a long-lived shared environment, and the consumers are Heroku VMs that sometimes involve kind of a manual configuration. If I write a new consumer that is listening to a new queue, I have to go into the platform and turn it on, as opposed to the CI environment where that happens automatically. So some standards for our tests. We want realistic and unique data per test. That's really important. Each test should get its own account. That's great for triaging issues because if a test fails, I want to be able to log into that account and only know that my test is the only thing running in that account, and then I'll be able to see the state of the world from that account's point of view. I want the tests to flex everything. I want them to fail fast. I want them to run in a shared environment. I want them to run in parallel. All your standard stuff. So that's how the tests kind of work. And before I talk about how we do the RabbitMQ part of the test, I'll talk about how data moves around in production. This might be kind of basic info for all you RabbitMQ experts. But so here's an example. Like when you add a location in the ReviewTrackers platform, you would do it right here. So you Google autocompletes, and then you create a location. So it's a pretty simple front end flow, but under the hood, so many things happen that aren't just like the synchronous post, right? So there are lifecycle messages that get kicked off that send that location record to Elasticsearch where it can then be searchable. There's also a routing key that creates landing pages so that people can leave reviews about your location in our ReviewTrackers tool. So those are kind of first party reviews for us. So instead of Google or Facebook, there's this new landing page that customers can hit to leave reviews about the location. And that all happens right when you add a location in our platform. But that's an asynchronous task. So that's done through Rabbit. And then there's some really downstream tasks where like we'll go out and find all the URLs associated with that location, your Google, your Facebook, your TripAdvisor, and then we'll pull data on that. So there's asynchronous tasks that build on other asynchronous tasks. So as you can see, like when you do that location create action, it creates a ton of other lifecycle messages. And then when we're talking microservice architecture, I just want to talk about the concept of idempotency, which is really important microservice concept. And it's the idea that clients can make the same call repeatedly and they'll arrive at the same result and they're not duplicating it. So for example, an HTTP GET request is idempotent, but an HTTP POST might not be idempotent because that would create multiple records, even if you called it the same exact way each time. And why am I talking about idempotency? I'm talking about that because at our company, our engineers regularly write maintenance tasks to loop over resources and re-queue messages. And the reason, and by re-queue messages, I mean, is maybe that lifecycle event over here, the one in Elasticsearch, maybe that ran the first time you added the location, but there's a suite of maintenance tasks where you can grab all the locations and resend them to Elasticsearch. And why might we do that? We do that because HTTP is the wild, wild west. Inevitably, requests can fail. We just want a way to if a customer reports, a problem with search, we can be like, okay, give us your account ID. We'll requeue all your resources in that microservice. And that's not harmful because you can resend them and it's no problem. They won't create duplicates of themselves. They will just overwrite the existing records because those are idempotent kinds of requests. And that's an easy way for us to triage things. If data is corrupt, you might want to loop over a series of resources and requeue messages. If you want to reprocess your insights keywords, maybe there's a new keyword algorithm and you want to reprocess, send them all through the AI network once again. So you can do that with these maintenance tasks, and it's not a problem. And again, in the review space that we live in, it's really a thing we need to do is recheck that things are active, recheck that listings are existing. So that's why we have this suite of maintenance tasks that loop resources and requeue messages, and those depend on the concept of idempotency, which is that you can do things over and over again and arrive at that same result and not create duplicate records. So how do we utilize that microservice concept to move data around for tests? So here's a sample test that I want to write as an end-to-end engineer. I'm writing a test for this location dropdown component. It's a very specific component, and I'm testing search. So let's watch it one more time. They type Chicago pizza. They see that only the Chicago pizzas are loaded in, and then they do a scroll action, and then the infinite scroll takes place, and we load even more Chicago pizzas. And before we typed it in, we saw every location. So we're seeing that in this kind of recreated example, like that's how the location dropdown works. We want to test that in our end-to-end suite so that we don't break it in the future. So if we're doing that, we don't want to add locations one at a time via the front end or the API. If we did it via the front ends, like we're doing right here, that would take forever for an end-to-end test. If we did it via API, we would be creating all these lifecycle messages that would be creating a bunch of extra data that we're not concerned with. We're only concerned with, in this case, with the Elasticsearch part of it. We don't care about the landing pages. We don't care about the URL associations. We don't need to go out and fetch reviews. We don't need to do any of those other actions. So we probably don't want to add locations one at a time by the front end API. So what I would posit, and this is kind of the key takeaway from my talk, is that tests can run maintenance tasks to get specific data in their place. So what the test does is the test creates locations directly in the database, not through API. And it creates only the locations it needs for its tests. And then we run one of these maintenance tasks to resend all those locations to the Elasticsearch queue and only do that. So let's say we're doing this, right? We're taking advantage of the maintenance tasks in the test. How do we wait for that asynchronous task, right? Because when you send data to Elasticsearch, you're queuing lifecycle messages. Maybe you're queuing 30 messages, and those take time to process. And you don't want to just put a hard sleep in your test to wait for that data to get there, because that just goes against everything I stand for as a test engineer. We want to wait intelligently. We want to wait smartly. We have the full power of CPUs and networks at our disposal, and sleeping is just a waste of that computing power. So some strategies for waiting intelligently are looping until the data is found. And to do that, you can use existing microservice APIs. If one exists that'll tell you if your data is there, you can utilize that in your test, or you can write your own API. In the worst case scenario, you can keep reloading the page until the data shows up if you don't have access to one of those APIs or you don't know about it. But that's really a worst case scenario. You should definitely pester your engineers to get you access to those APIs to tell you if your data made it to that other system expediently. So let's talk about why to do it that way. This is a great way to do it because it's not too artificial. you don't need your tests to connect to all the microservice databases. Really, they can connect to the one database and then have data be pushed out to those other microservices in a somewhat natural way. Microservices can then also own their own data definitions. You don't have to know about the data, the shape of the data in all those different places. It's less maintenance if the microservice shape of that data changes. You'd only have to change it in your tests where you're writing the record for its first time. So you don't have to change multiple places. When you do it this way, it's less cleanup. We're not creating those landing pages. We're not creating those reviews. We're not creating those URLs. It's also faster setup. Yeah, so I think it's a really good way to test. And so I want to go into the weighting logic a little bit because I only covered it really briefly, but so let's talk about that. And by weighting logic, I'm talking about how do we wait for that asynchronous thing intelligently from the test perspective. So here's a sample of what that might look like. So we have this thing called maintenance task helper that is the thing that runs that maintenance task to send all your locations to Elasticsearch. So we just pass it the account ID, which through foreign keys has access to all the locations. And then we tell it which record to index, which would be the location record. Then that's on line 10. And then on line 11, we have a piece of code called check for index record, where we just take one of those location IDs and let me describe check for index record right here. So what this method does is it hits an already established API in the Elasticsearch microservice. So Elasticsearch is a third-party tool. We didn't write it. It's just a search database that exists out in the world. And there are ways to ping that to know if a record is present or not. And something important to talk about, and so this is line 81 that I'm talking about, where we're creating this URL to hit. And yeah, something important to mention here is we're querying Elasticsearch directly, and this is different from how the front end might query it. This is how the test is querying it to know at a glance if a record is present or not in that microservice. So it's kind of a smoke test. So you can see some other kind of interesting things in this method. So essentially what the method is doing is it's looping until the record is found, until that one ID for that one location is found. And on line 90, there's an interesting piece of code that if we ping Elasticsearch and we don't get a 200, we instantly error. So that tells you maybe there's an issue with Elasticsearch right there. Maybe Elasticsearch is down, something like that. And then on line 99, we have an elastic not index error. So that means that we looped for the full amount of seconds, 80 seconds, and we still couldn't find the record that we were looking for. And then that tells the triager, okay, maybe there's something wrong with shoving the data into Elasticsearch. Maybe there's something wrong with our ETL, something wrong with Rabbit in that regard, but we know where to look. So yeah, so this is what that error might look like. It's really helpful. It tells you what resource we were expecting a record to be in, and we give you the raw response from Elasticsearch, and you can easily go off on your day and triage. So I'll give one more example of some weighting logic that we have at ReviewTrackers. For that example, it has to do with Amplify, which I think I mentioned before. It's for embedding widgets of your reviews on your websites. So if you're a Pizza Hut and we've collected, hundreds of thousands of reviews, and you use Amplify, we've selected, 6 of those reviews, and then we give you some code to put on your website that just selects 6 of the really good reviews. So that is a service that we own, and here we wrote a private API to know that data made it to Amplify so that we can begin our test of the embedded widgets. And so line 11, we're turning on Amplify in the test. Line 12, we're doing something called like replay account settings. And what the idea there is when you're in an environment and you turn on Amplify, turn on Amplify in the front end, that starts the process under the hood of moving data over to Amplify so that it's available for the widgets. Since we are just turning on Amplify from the database, we're not, none of those lifecycle messages get kicked off. So again, we're doing them manually. We're running those lifecycle messages here with the maintenance task helper. And then we have this other interesting line of code, line 13, Amplify helper, wait for Amplify reviews, where we have a private API that I wrote specifically for testing that data made it to Amplify. So what that looks like is something like this. As you can see on line 67, there's a private part of the URL, and it just returns the review counts. And again, we're looping in line 75, we're looping over and over again until we hit a successful response. And then if we hit a successful response, we get the review counts, and then we match it with our expected review count. And then if we have our expected review count, we'll continue on with the test. But if not, we've got a couple of different errors we can raise here. Line 77, we can raise an Amplify error if Amplify is down, or if it's not returning 200 immediately, or it's not available. And then line 87 is a really helpful error because that tells you, we waited the expected 20 seconds and we weren't able to get, not all the reviews made it to Amplify. Maybe we expected 40 and there's only 30 still at Amplify. So then we don't even have to go embed a widget. We know, okay, there's something wrong with our ETL. There's something wrong with the data moving to that microservice. We don't have to continue with the test. So I just threw a lot of information at you. Let me talk about some other great uses of RabbitMQ for tests. Something that I absolutely love and I instill all of you to do is to check your queues and consumers with the RabbitMQ admin API in a before hook for each test. This is what that looks like. So as you can see, we have this queues array from 8 to 13, and then we've got this line 14 called consumer helper.check for consumers. And let's describe what that does. So here we're looping over each of those queues that we just passed in, and we're going to error immediately if we don't get a 200. And what that means is the queue doesn't exist. Maybe it's not declared by the software under test. And that's great that we have that, because this has actually helped us with our Heroku infrastructure. I think I described it before, but when developers add a new consumer or a new queue or anything like that, they have to turn it on in Heroku manually. So here we know, if that developer forgot to do that thing, it'll raise an error immediately, and we don't have to do more investigation. Another really helpful one is the consumer not bound error. So here we're parsing the output of the RabbitMQ admin API, and we're looking at the number of consumers. And if it's 0, we'll raise that consumer not bound error. And that's really helpful because if there's no consumer bounds, you're not going to get the expected work that you expect to happen in your application. So why even boot up the front end if the data is not going to be there? Here we know, from the first thing that the data is not going to get there, and we know why. The queue exists, but the consumer is not bound for some reason. Maybe it hits some kind of exception. The networks being what they are, consumers can bind and unbind themselves. You never really know. So this is just a really helpful thing. Hopefully there are other errors that go with this, in your other observation kinds of channels. But then there's another thing we've added recently, which is if a queue has too many messages. And for us, the threshold is 50,000. It might be different for different queues that process things faster, but this is great so that at a glance, okay, the reason the work isn't going to get done for this task is because there are 50,000 messages. Mine is first in, first out. Mine's at the top, so it's not going to get there in an expedient manner, and I don't have to troubleshoot. So I think these kinds of smoke tests that are in before hooks of tests are really useful. And here's a sample of what it might look like if one of those check for consumers calls fails. here we can see RabbitMQ maybe isn't even up, so we can investigate that instead of any of a number of other things. So I like to think these smoke tests are kind of like weather reports. They tell you at a glance what it's going to be. Do I need to put on a jacket? I guess the equivalent of like having to wear a jacket is if you get the queue has too many messages error, then you're like, okay, the temperature's hot today, and I know that from looking at the weather report. So I've already kind of said these things, but if data isn't found, you don't have to comb the front end. You know which queues to check. You know which consumers codes to check. A couple of things that could go wrong is maybe consumers are slow at processing data lately, or there's a lot of work for that queue at the moment. Maybe, if it's in a shared environment and someone just added 1,000 test locations, that could get in the way of your test that is adding one location. So those are, where to look. And then some other really cool things that we do with this strategy is if you need help looking for your issue, you can turn on logging. You can have tests declare which records it's sending to the maintenance task, and then you can trace those records in the software under test. Like, did it actually make it to Amplify? Or you can look at the consumer logs to see if that ID appears in a payload or something like that, and which consumers and microservices to look in because that's all declared at the top of the test. And I talked a little bit about before the slowdown in processing and that getting in the way of this kind of style of testing. So things that are helpful to triage that are monitoring queue size over time to see what is regular traffic, what's regular processing speed, what's not. If developers introduced code that makes a consumer's processing speed way slower, you could probably tell that from this kind of chart, and that'll be related to why data didn't make it in time expediently. So yeah, more data helps. At ReviewTrackers, we use a product Datadog, and we have it to monitor our RabbitMQ instances to get queue sizes over time. So that's a really helpful metric for us. So some dangers of this approach are when you have a shared environment, manual workflows can get in the way of the test work. I think I described that earlier. Sometimes when that person adds those 1,000 locations, I'll ping all the engineers and I'll be like, hey, is anybody testing locations right now? And one person will be like, okay, I just added 100. Yes, I just added 100 or 1,000 locations. And I'll be like, well, I need to run this test for this deploy. Can I just purge them? And they'll be like, okay, sure. And then I'll purge them. We'll run the continuous deployment test. And then once that's done, we can requeue all those location messages with our maintenance tasks. So shared environment, manual workflows can get in the way, but it's not the end of the world. We can requeue things if we need to. So with that strategy, hopefully, we'll get our realistic and unique data. We're not doing anything too unnaturally. We're able to fail fast and clearly. We can run it in parallel because queues are great at that, about just, waiting for data and putting it in a queue, and we can run in a shared environment. So what are some other things that RabbitMQ can do for us? So I described the ephemeral environments that we run for CI testing, and we have a health check script that loops through a list of queues that tests use and waits for them to have consumers bound before even starting the test. So that's kind of a non-standard health check that we have, and I'll show you what that looks like. So here's like a list of really important queues that we know the test depends on, and then here on the right, we're just looping, and on line 58 we're calling check for consumers, and that is checking to see that all of those queues have consumers bound. And once we know that all those consumers are up, then we can start the test. So it's a really good, at a glance way to use RabbitMQ to just know, okay, is my environment in a good state? There are a couple other things we put in the script, like we have check for inhale, check for search, check for scorecard. Those are other microservices that were slow to boot up. So we wanted to know if those were up too before starting the end-to-end tests. So put that in the script as well. And what's really nice is we raise the error that these services raise if our timeout is hit. So if we have a problem with a specific queue that's in this list, we'll know it. Line 84 will show us that that is the queue and the problem queue. So as a tester, I just really appreciate RabbitMQ and use it, in my day-to-day testing. And I think that if you understand a little bit about it, it can help you in your day-to-day. Like, for example, understanding topics is really important, like the difference between a life cycle and an event and like a task that comes from a webhook or a maintenance task. If I see a topic that a developer's adding, I'll know what kind of thing that they're programming and what they're doing. So I always look at that. I also like to check the delivery speed of new work as it comes out. And some really fun test cases that I love to do is to simulate delayed processing. And to do that, I'll delete a queue and then I'll do a workflow and I'll see if the website handles data not being present yet for that new work. When you make a new resource and you have a new front end page to look at that resource, you should be able to handle the empty data state. And what's a really easy way to get in that state? It might be deleting a queue so that nothing feeds data there. So another thing I like to bring up is that I always ask the developers, can your consumer handle parallelization? So I'll often be booting up extra consumers for new ones that are being released, and I'll do a workflow and I'll see if that results in duplicate messages or duplicate things in the application under test. So that's why it's good to understand a little bit about RabbitMQ. We even use RabbitMQ to train developers how to triage issues. And the way that I do that is we have this training session for new developers, and we'll boot up an ephemeral environment and we'll say that a customer reports that data is not coming in for the new account. And under the hood, I am running a kill stop command for a particular consumer. So what that does for it is it still shows that it's bound in RabbitMQ admin, but it's not actually processing new work. And we don't have heartbeat set up. We probably should, but that might actually catch the scenario. But in this case, like if you load up the admin, RabbitMQ admin, it shows that it's bound, but it's not doing anything. So the solution is the developer needs to figure out which is the affected consumer and see that the messages are stacking up and nothing is processing them, even though it's bound, and then they might restart that consumer, and that's how they would fix it in this case. But understanding Rabbit enables me to enact that test. So that's my talk. I think I'll open it up for questions. I don't think I have time for the extra time part, but I'll just kind of leave this up.
Thank you, Zach, for this talk. It was really good. I know why we invited you, because you delivered this talk about how to test with RabbitMQs. We heard quite a lot of good ideas what you can do to make the whole environment end-to-end more resilient. It's not just RabbitMQ. If you have any questions to Zach, please ask your questions in the Who app. And we still have about 5 minutes to ask questions. While we are waiting for questions to arrive, I have one. You did quite a lot of testing in the test environment and make sure that nothing goes into production that cannot be handled. Did you have some slips or still production issues with RabbitMQ?
I think we've definitely hit this issue before, where a consumer or a new consumer process declares, I believe, a channel and an exchange for every message received. It's not reusing the existing connection. That was not caught in our CI/CD tests because that only manifested over time in a long-lived environment when that consumer eventually started crashing. So we weren't able to hit that. We weren't able to find that configuration issue with this style of tests. But something that this style of test is really good with is seeing that there might be differences in the long-lived environment versus the ephemeral environment with the size of data that we're processing. For example, a test might be really quick in CI, but in CD, the consumer processing it is way slower. And we know that because we have multiple tests using that same consumer, and we'll see the messages stack up, and they're not being processed in an expedient manner. And then we'll get that queue as too many messages error, and we'll know right ahead, like, okay, this doesn't meet our values for how fast a queue should be for it to be testable in this way. And sometimes we can only know that with a long-lived environment with more realistic, larger data sets. But it's really good to know about it before production.
And how do developers find these trias to find issues in RabbitMQ?
But I'm sorry, can you ask that one more time?
So how do developers find the trias that you set up with RabbitMQ?
They really liked it because we'd only seen that kind of issue maybe once or twice in production where a consumer was bound but not doing any work. So nobody was thinking of it. And it was a good experience for them to hear, a report from a customer and then think, okay, what consumer actually does that work? And, it was something that was pretty downstream from the initial data that was missing. So they had to do a lot of investigation. And then the funny thing is, like, they don't know how to, they weren't sure how to fix it. But it was a simple restart.
Yeah.
Sometimes developers can be hesitant to do that because they'll be like, oh, but that might put messages in the dead letter queue. But then you get to educate them and be like, that's fine. That's what the dead letter queue is for. And then you can shove those back into the regular queue. So good education moment.
And if I understood correctly, you are using the Ruby client and
yes,
Ruby. So heartbeats might not be the best approach for you if you have a lot of single-threaded applications. So just be careful. You mentioned heartbeats and introducing heartbeats. That might not be the best approach to detect, for example, misbehaving clients.